Hello and welcome to a new video. It's oscilloscope review time, and this time I've got an exciting model to look at. It's the new Micsig tablet oscilloscope. This is model number STO1004, and I think we'll be seeing a lot more of these going forward as the industry seems to be heading this way. Whether that's good or bad thing, I'll let you decide, and maybe you can share your view in the comments below. Full disclosure, Micsig have sent in this scope for free for the purpose of this review. And they already have a bunch of different models in this format. They went through several generations of these. People seem to like them. They're popular because they're fairly well priced for the specs they offer, and they are built with great quality. The specific model that I have here is 100 MHz, 4 channels, 1 GB samples per second. It has a memory depth of 70 meg points, an 8-bit ADC on the input, 1 mV per division sensitivity on this model, and it can do 130,000 waveforms updates per second. It has this nice industrial 8-inch TFT with an 800 by 600 pixel capacitive touchscreen display. The screen itself is glossy, but it does come with a matte protection film included in the package, which makes it look very nice. And by comparison, Rigol DS1054Z, which I have been using for years now on my workbench, it has the same 1 gig samples per second, but with just 24 meg points, so the Micsig will be able to capture more data points onto which you can then zoom in and analyze. By the way, if you'd like to check out the cost of this unit or purchase one, I will be placing links to authorized resellers in the EU and US where you can order one. It's got the usual UART, LIN, CAN, I2C, SPI serial bus decoding functionality plus more. One nice feature that I was glad to see is their universal probe interface right here on the top. They have these auxiliary pads here for connecting to each probe, and when you use active probes or differential probes or other smart probes from Micsig, they can connect to these pads and they can be powered and they can be automatically detected by the scope. This is a feature that you typically see only on higher end scopes. Being a portable scope, it obviously has a lithium-ion battery in here. It's 7.5 amp capacity. It's removable. You can purchase replacement ones from Micsig, and they quote a 5-hour battery life, which I think can only be achievable with a reduced screen brightness. I ran a test by having the brightness set to max, all channels enabled, and matte FFT enabled, and it lasted just over 3 hours doing that on a full battery. Videos like this wouldn't be possible without our channel sponsor PCBWay.com, a professional PCB manufacturer with excellent quality and fast turnaround times. Right now they're running a big Christmas sale on their website, so it's a good time to place your PCB order. You could also try them out for many of their other services like 3D printing, CNC machining, and manufacturing in general. Check out their website, link below. On one side of the scope you get this carry handle, and on the other side of the scope we get a bunch of things. Here is the soft power button which lights up. We have the test signal connections. There's 2 USB, one is USB 2.0, the other one is 3.0. There's a regular HDMI out port, a USB Type-C port. Both USB Type-A ports can be used for plugging in external storage, while the USB Type-C port is used for connecting to a PC, which exposes the internal memory of the scope for downloading the stored data. Unfortunately, it does not take power via the USB Type-C. That would have been a nice feature to have because you'd have to carry one less power adapter. Fortunately, we don't get that, but we do have a physical sliding power switch which overrides the soft one, and this can be useful while the scope is packed to prevent accidental turning on through the soft power switch. There is a cooling fan on the back of the unit, and it's running pretty much all the time. It is temperature controlled, but it is running pretty much all the time to keep the scope cool, unless it's very cold where you are operating this. The noise it makes is pretty much similar to every other scope with a fan, but I don't think that matters too much for a portable scope. What matters is that you have a bunch of openings, so dust or water can easily get inside the scope and damage it. So even though it has this like rubber holster on the edges to make it more rugged, care should be taken to operate it away from dust or water. The weight of the unit is 1.9 kilograms. Its operating temperature range is between 0 and 45 degrees Celsius, and on the back we also have these very nice tilting feet. These work great, and I do like them very much. I do like the position it puts the scope in. Inside the scope box, I also got 4 of these standard Micsig P130A passive probes. There's no attenuation adjustment on these. They are fixed ×10 probes, which is kind of a bummer. I often do measurements on ×1. Also inside the box, like I mentioned earlier, you do get a matte screen protector, which I think is a great idea to include. But since I did a fairly bad job at applying mine, I do have a couple of bubbles here, another one here. It would have been nice if they would have included maybe 2 of those protection screens so that I get a second chance at applying one. Nonetheless, it looks much nicer with the matte film. Also inside the box you get one of these 12 volts 4 amp power adapter for charging, and that's about it. No carry case included, but Micsig does have an optional carry bag for their portable scope lineup, or you can order just a standard laptop carry bag and use that, or like a hard EVA case from AliExpress, which I have ordered and will be showing soon, whichever you prefer. Boot time is pretty long on this unit. It's approximately 35 seconds from start until the scope is operational, but that's pretty normal with this type of scope because it first needs to start the operating system, then the oscilloscope app, which runs on top. And this, by the way, is running a heavily customized Android 11, on top of which is running some custom Micsig apps. It has 32 gigabytes of internal storage and Wi-Fi connection capability. The Wi-Fi connection is useful for software updates, for installing additional software, or for sharing the screen of the scope, just like you would do screen sharing with any other Android device, like your smartphone. There's also the option of a mobile Android or iOS and a PC app for controlling the scope over Wi-Fi or USB. The user interface of this scope is both touchscreen based and button based, which I think is offering the best of both worlds. I know the vast majority of users don't like to use a touchscreen on an oscilloscope, but for some things like, for example, an on-screen keyboard, it can be really useful. Also, if the touchscreen interface is well designed, like it is the case with this Micsig oscilloscope, it can be very intuitive to use. I would say that in my personal experience, 90% of the stuff I was trying to do on this scope while reviewing it, it felt intuitive and easy to find in both the touchscreen and the button interface. I didn't need a user manual at all to learn how to use this scope. Regarding the button input, we do have several well-defined sections on the right hand of the scope, and at the top we have the typical run, stop functions, as well as the single capture, screenshot and auto setup function, which by the way works really fast on this scope. Next we have the general menu and navigation controls, and through the interface, instead of rotary knobs, they have used these directional joysticks with these blue thumbsticks. I'm not a big fan of these. I mean, yes, the implementation is done right. They respond nicely to input. There is velocity sensing, so if you keep one of these pressed, it will accelerate, so it's fairly easy to get to the desired adjustment point. But it's just something with rotary knobs and oscilloscopes, the feedback that they give you. I would very much prefer a rotary knob instead of these joysticks. Next up, we have a joystick here for trigger level control, and it's not immediately obvious, but the channel which is selected for a trigger does have a full arrow here on the left side of the screen. So right now we have channel 1 selected, but if we were to select channel 2, for example, you'd see the full arrow switched to channel 2. And here's something annoying: this selection menu does not disappear after you have confirmed by pressing the joystick. You also have to press this key to return to the screen. In my opinion, that should have been automatic. The menu should have gone away once you have confirmed the selection. Things that were a bit more difficult to figure out on the UI were the math and decode functions. So first you have to enable that menu by pressing the math button, which brings up these options on the sidebar. And right now, when you select one of these options, like on the top we have the actual math option, while on the these two S1 and S2 are the decoder functions, and we also have the reference function. So once one of these is selected, you can then press the menu button in this section to control the actual options for that function. And if we go to the decode function, you can see that we can enable all of these, or we can turn it off. So next on this section we have the input channel adjustments, and we also have a menu system which feels pretty intuitive and easy to select with a simple touch of the screen, or you can do it from the buttons. And this is where I think the touchscreen has its advantages. We can adjust the position of a certain channel on the screen, we can move it left to right, and all of this can be easily be done with a touchscreen. We can also adjust the time base, for example, with these buttons on the touchscreen, but we also have the physical joystick that we can use for adjusting exactly the same things. Then we have a couple more buttons at the bottom. Here we have a screen lock, which enables a touchscreen lock, and we also have a home button which works exactly like a home button on an Android device, bringing you back to the home screen. They also offer updates for the scope over the air. However, be prepared for very long download times. For example, when I first powered up the scope, it offered to update, and while the update process was quick, the download of the update took several hours to complete. One nice feature is that they include this very easy screen capture functionality, both as still image, which you can trigger from the button directly, but also as video capture, which you can trigger from the menu. And that's something that I've always wanted to have in my oscilloscope, because if I'm working on something and I want to share the data that I'm capturing with someone else to get a second opinion, it's very nice if I can do that as a video capture with multiple events captured in that recording. The scope also has other very convenient features like color temperature mode, or adjustable persistence mode, or the very useful predefined channel labels. Remember how long it took you to label your signals on your standard oscilloscope? Now you can just pre-select from the list of the most useful tags that you can put on these signals, and if you need to define a custom one, then you have a full keyboard to take advantage of. Oh, and by the way, this supports external keyboard mouse as well, but I don't think you'll need one with this touchscreen. I think by now everyone is screaming at the screen, do the teardown, so I had to remove the rubber holster, a bunch of screws, get out the battery. It took me a good 10 minutes of prying open this holster from the scope unit, and this is as tight as it gets. I have never seen a piece of instrument until now that has such a tight holster around the main enclosure. This is like a perfect fit. It's almost like you'd think that it is overmolded and not a separate piece, but I managed to get it out in one piece, and now it's time to get a glance inside the main unit of the oscilloscope. This comes off nicely. You can see a couple of magnets on the back of the case and the cooling fan, and everything is nicely shielded in here, but it looks like the front end shields are not soldered, so we might be able to take one of those off to take a peek inside, and this one is obviously tied in with screws, so we can remove that to take a closer look. So I'm gonna start by mentioning a few interesting construction details. By the way, all of the assembly is absolutely gorgeous, top quality soldering and layout of the PCB. The shielding cans for the input side are not soldered, but they are clamped in place, which is great for teardowns. The input BNCs interestingly have these ring magnets on them, and there is another set of magnets on the like the front plate that goes over the BNCs. So I'm not sure what the deal is with all of these magnets. Maybe they have some functionality with some of their more advanced active probes or something like that. I don't know. If you know about these magnets, please let me know in the comments below. They've used this very interestingly looking pin header style of pogo pins to interface with the front panel PCB, but they also have a flat flex on this. So yeah, I don't know why they bothered to also have a flat flex if they could have done it via the pogo pins. This particular PCB has a manufacturing date code of 31st week of 2022, which puts it at the start of August, so a fairly recent unit and revision. The revision code for the design itself is version 1.0 with a date code of May 2022, and the application processor sits on its own little module. These are typically called SOM, system on module, and it uses the SODIMM form factor, and judging by the silk screen here, it is based on the RK3568. Now, the RK3568 is a very popular name, a very popular SoC for Android development. It is made by a company called Rockchip, and besides being very well priced, they provide good support for building Android hardware around this SoC. Many of the Chinese tablets are based on this system on chip or its relatives. The fact that they used a module in this SODIMM form factor kind of makes sense. I wasn't expecting it, but this splits development of the oscilloscope board from the SoC, so you can easily upgrade to different SoC, different flash size, different RAM size after you've completed development. Then you just have the standard interface on your oscilloscope board. You can also have maybe Rockchip or some other OEM make these SODIMM modules for you, so you don't have to worry about these anymore. I'm expecting an FPGA to be under this heatsink, and I will remove this in a minute to confirm if it's not somehow stuck. I will include a screenshot of this. The ADC they used is from Analog Devices and is the HMC AD1511. This is an 8-bit capable of 1 giga sample per second in single channel mode. This big guy here is a 9 megabit SRAM chip, likely used by the FPGA. There's also some DDR4 256 megabyte chip right next to the FPGA, and there's like a bunch of switch mode regulators scattered all around this PCB. On the back of the board we have what I believe to be a Wi-Fi module, and this is the part number AP6181. This one is based on a chipset from Broadcom, and I suspect that this was included in the app note of the Rockchip system on module, and the Rockchip might be providing drivers for easy development with this module. Strangely, I don't see an antenna here. I think it was supposed to be here, U79, but there isn't like a PCB antenna and neither a chip one, so I'm not sure what's happening here. Also on the other side, but on the top side of the PCB, there is what looks like unpopulated components for some kind of radio chip. Maybe they were just providing two types of Wi-Fi connection chipsets to this board, and they didn't populate this discrete solution. I am not an analog expert, so I won't be talking about the front end of this scope, but there will be high resolution images on my blog post if you would like to take a closer look. The 100 MHz bandwidth is nothing to write home about though, so it should be a fairly standard input section here. We also have a secondary PCB to handle the button interface, and the microcontroller here looks like an STM32 clone, and by now I would expect pretty much everyone except the big names like maybe Apple, Microsoft or Tesla level to have switched to using STM32 clones just because of chip shortages. The clones are available while the original is not, and that's for years to come maybe. So that's about everything happening in here. Now I'll just need a second to put everything back together. Now, before sharing my final thoughts of this unit, I'm going to be answering some of the questions you guys posted on my YouTube community post, because I asked what would you like to see tested about this scope, and Alvaro wanted to know how long the battery lasts. I've already answered that. That's between 3 to 5 hours depending mostly on the screen brightness setting. Another user, Butterparty, wanted to know the advantages of such a battery powered scope versus a traditional one. Well, it's the obvious portability for a start, which can be a huge advantage, and because it's battery powered, you also get one huge advantage in terms of electrical safety, because the ground probe on this battery powered scope is not mains earth referenced, which makes it a little bit safer to operate when probing mains powered stuff. You can still blow up the scope if you, for example, tie two of these ground leads to two different potentials, because they short on the PCB of the scope, so there's still good potential for blowing stuff up if you don't know what you're doing. And another potential advantage is if the scope is well designed, and this Micsig certainly is, it can also provide you with a lower noise floor. Another user, Frank, wanted to know how fast an FFT can be calculated and refreshed, and if it does any decodings. Well, it does include multiple decoding protocols like UART, SPI, I2C, CAN by default, and in terms of the FFT, I'm not sure how to measure how many updates we get per second. Maybe we can use that auxiliary output on the scope to test that, but I would say that its FFT capabilities are pretty limited. It doesn't have any dedicated hardware to do that, so it maybe gives you 1 or 2 updates per second, as it can be seen on this screen. But it does come with advanced math capabilities, which might be useful to compute on some type of waveforms that you might need to see. And now to give you my final thoughts on the scope, I would start by saying that Micsig have been in the business for a long time by now, and they know what they're doing. Their scopes are pretty popular already. Many people are using them. This is a great model for those looking for an affordable battery-powered portable tablet-style oscilloscope. Sure, there are some downsides to using a tablet-style oscilloscope, like you get these joysticks instead of rotary knobs, although they do have they had other models in the past which had rotary knobs. The input is fixed at just 1 meg, the ADC it's just 8 bits, but is that going to be a problem for 90% of use cases? I would say no. This is perfectly adequate for getting the job done and for its price range. Would I get this as my main workbench oscilloscope? Probably no, because of the joysticks. I wouldn't want to be fiddling with those every day, but if this has rotary knobs instead of joysticks, I would absolutely get it as my bench scope. As a portable secondary scope, I think it's great. It's compact. It has these great features for screen capture, signal decoding. It can store waveform in multiple file formats, and you can easily download those and analyze them later in your software of choice. I haven't played with their mobile or PC app, but just having that Wi-Fi connection and the capability to share the screen over Wi-Fi is a great feature if you want to show the scope screen on a larger screen. So it can work as a benchtop oscilloscope if you can get over the fact that it uses joysticks instead of rotary knobs. The choice is yours. Should you decide to get one, please check out the links I've placed in the description of the video for authorized resellers of this oscilloscope. Thank you for watching, and I'll be seeing you next time.